So you want the forces to be balanced. So you have 50 G going down from the beam. So you have 25 G at A and then 25 G at C.
And 25G.
And then I guess would you need like the moments to be equal to 0 and like the forces?
Yeah.
Like you need to be in equilibrium. So if you take moments at about C, then you'll have 25G times 1.8 anti-clockwise.
Mm-hmm.
And then 35G, and you don't know the distance.
Uh-huh. So how could you represent that?
And then 85G times 0.2.
85?
Yeah, wouldn't that be like the M, the support?
It's 25, isn't it? 25G?
But wouldn't it be everything added?
No.
Because it has to balance all the downward forces.
So they just are where they are. So Sam has in uniform. So it's 25 kilos and length 4. So the 25 kilos is at C.
Yeah, but wouldn't the like support need to balance? Because there's no like upward force. Only like forces. There's only weight forces going down. So the
So
forces aren't balanced.
we just need to look at the rotational forces.
Okay. So you don't need. Okay. So you don't need to count that support thing.
So that would just have like, you could think of it as a reaction, but we're just looking at it kind of rotational forces.
Okay. So you don't need to count that then.
Yeah.
Okay. So yeah. So then it would just be the force at C, 25G times 0.2. Wait, no. We're doing it at C, so you don't include that one.
Mm-hmm.
So you just have to figure out like how to make that equal to 0. Right? Or is there anything else?
So you don't have you haven't put an unknown anywhere.
Oh, the distance for the 35G
So
is the unknown.
okay. And in relation to C, is that positive or negative?
Negative. It's going clockwise, yeah.
And that's what you'd solve.
I got the distance as 1.29 meters.
And so, is that where Sam must sit?
Yeah, 1.29 away from C.
And so, what would it be from A or B?
3.09
So 3.9
from A.
from A.
Mhm.
I got 3.57 from A. 3.57. Let's take a look. So you took moments about C. So that's 1.8 times 25G. Would have to be equal to... what is this one?
35G.
So this is going to be negative, and then 35G times X. So one. I think just take moments about M, because we don't know what's going on with the M.
Okay.
With forces and stuff. Yeah, just take moments about M. So what would that be?
So that'd be 25G times 2. And then plus 25G times 0.2. Minus 35G times D is equal to 0. I got 1.57
So that is 1.57 from M.
M. So that's 0.43 from B.
Okay, so 0.43 from B. 0.43 from B. Yeah, so we have this reaction here, but we didn't know what that was.
Okay.
And so, I mean, that's what it's pivoting around anyway, so we'll take moments about that. Any questions there?
No.
Okay, how about this one?
So should probably draw a diagram first.
Mm-hmm.
Well, you know that C, like the force at C, is equal to 3 times the force at D.
Mm-hmm.
You can do C is equal to 3D.
Okay.
And then you can do, because you know what the weight is, so you can just do like 3D plus D is equal to 20.
Mm-hmm.
So then you can figure out what D and C are. So D is equal to 5 and then C is equal to 15.
Mm-hmm.
Then you can just pick a point and do pivot and take moments about it.
Mm-hmm.
So I guess you could do like A. because you have to find the distance from A anyway. So you have to do 15 times 1 plus 5 times 2.5 plus, wait, no, not plus, minus 20 times D is equal to 0. And then solve for D. So D is 1.375
0.375 meters. And yeah, they rounded it to 3 sig fig 1.38. Great. Any questions there?
No, that wasn't that hard.
Okay.
Okay, so the center of mass is like 1.25 meters from A. So that's where the weight is.
Okay.
And the weight is 25 newtons. So I guess you'd take moments about A. So I think it would be 25 times 1.25 sine 20.
Okay.
But I'm not sure if that's right.
Looks good.
Sine 20, yeah.
Sorry.
And then minus, you don't know what the force is. So, but you could do, wouldn't it be like 2 sine 20?
Yeah.
And then like F, I guess, for the force.
Yeah.
Equals 0. So you just solve. F is 15.63 newtons.
15.63?
Yeah.
14.7.
Is that because there's like a force where it's touching the ground or something?
25 minus 15.63. No. If we take moments about A. So the one thing, the reaction for this one. So we were doing 25 times 1.25 sine 20. And then minus 2, could it be cos 20 times x?
What? Oh, I think for the second one, it's just 2 meters. Like the perpendicular distance is just 2 meters.
Might be 5.6.
Because it's like, I don't know how to explain it, but it's not going like straight down. Like
Yeah.
weight forces.
Mm-hmm.
So I think the perpendicular distance would just be 2 meters. But that would give you Yeah, that gives you like 5.3 though. Yeah, which doesn't look right.
I just wonder, is this question in the right place? A non-uniform rod of length 3 and weight 25. So it's weight of 25, rests on a smooth peg, 2 away, the end rests horizontal ground. So that's 20 degrees. So this force here, so it's definitely 25 times 1.25 sine 120. So we have some reaction here. Or is it straight up?
I don't think it would be straight up. Wouldn't it be just...
So like that.
Yeah, maybe.
So that is...
I don't know if that would be 2 meters or 2 sine 20. But if you drew like lines, it would be 2 meters. So
I don't know. I'll see. I'm not sure if I might have put it in the wrong place. Anyway, we'll see. Okay, let's try this one. See, this looks like the ones we were just doing, except kind of more of it. Okay, let's try this one.
Okay, so the only forces is like the tension in the ropes, yeah. And then there's mass. I don't know, is it like, is the center of mass in the center, or do you not know?
It probably says it's modeled as a uniform rod.
Okay. So then, but then the second bit does not make sense. Oh, there's a new thing. Okay, never mind. So there's 24G at 2.4 meters. Yeah. And then there's at C, there's 15G. So you just have to like take moments about a point. So since you need to find the tension at B, I think you should take moments about A.
Okay.
So that would be 15G times 1.4. And that's clockwise.
So plus or minus?
Minus.
Yeah.
And then minus 24G times 2.4. And then plus 4.8T is equal to 0. So solve. T is 160.475. Do you get that? Plus
113.31?
No.
What was your one?
160.475.
That?
Yeah.
I might have put it in wrong. 160. Okay, I just put it in wrong. So it's roughly 160, 3 fig. Okay, part B.
Okay, so now it's non-uniform, but the tension at A is 25 newtons greater. So since you know, like, what the tensions need to add up to.
Mm-hmm.
You can figure out what the tensions are. So B is equal, wait, no, A is equal to B plus 25.
Okay.
So then B plus 25 plus B, so 2B plus 25 is equal to 15G plus 24G.
Mm-hmm.
So when you solve for B, $178.6, and then that means A is,
And was it exactly 0.6 or was there more to it?
yeah, it's exactly 0.6.
Okay.
So A is 203.6.
Okay.
Find the distance. Okay, so now you can find the distance because you know. And then since you need to find the distance from A, I think you should take moments about B. Oh wait, no, about A. That doesn't make any sense. So then you can just ignore the tension force. And then 15G times 1.4 minus 15G. But minus 24G times D plus 178.6 times 4.8 is equal to 0.
Try that.
I got 2.77.
And 2.77 meters. 2.77 meters. Great. Any questions there?
Well, this actually isn't that hard.
Yeah, it's all right. So I just want to see, this might be just similar. Non-uniform. Vertical ropes, tension. I think you're okay there. Seesaw. So it's finding an unknown distance. Seems similar. I think you'd be fine for this.
Yeah.
And then this.
Mm.
See, hang on. See, this one just has the answer. And that, I think I might have, the other ones have the worked examples, the worked answers. And so I think I have this one in the wrong place. I just want to take a look at it.
So the tension in the rope is 100 newtons. And so the only other force is like the support and the weight. So I guess you would like take moments about A.
Distance. So, is that right?
And like, wouldn't the angle be 45 degrees? Because I think it's a right angle triangle.
The non-uniform rod is 3. The non-uniform rod length 3. So that means that this bit must be 2.
Yeah.
And why do you think it's 45 degrees?
Because it says the fixed point P that lies 2 meters vertically above A.
Right.
So I think it's right angled, but it might not be.
Like a right angle is 90 degrees. So how are you getting 45?
No, that angle, like PBA, is 45, I think.
Yes, but why?
Oh, you don't know if the sides are the same length.
I mean, we kind of know they aren't.
Okay, never mind then.
Base is 3, height is 2.
Then how are you meant to do it?
What is the hypotenuse?
100.
I don't think so. Tension is 100. That's me representing that. But if this is 3 and this is 2...
Oh. Then root 13.
Does that help?
But you don't know what the angle is, so you can't do distance.
You might not know what the angle is. I'm sure Sakatoa knows. Opposite over hypotenuse.
Well, that trig. 33.7. I still don't really know how to do this, but
I'm not sure if it's in the right place. Given that the tension in the rope is 100, work at the distance, the center of mass from... Nah. Okay, so we did a lot, but I don't know. See, all the questions look like this. And then it's just those weird ones. Show that is that. Non-uniform rod, 25. Weight 80.
These questions.
2 support. Center of mass. Rod is 10 meters from A. Yeah, you're going to be fine. You're going to be fine with that. Then this one is tension again. Tension in the rope at A. Tension in the rope at B. What would be part B?
Wait, which part? Part B?
Part B.
Comment on the assumption that the ore can be modeled. Do you just say the center of mass is not in the center? Or?
A non-uniform rod.
Oh, can be modeled. No, it says can be modeled as a uniform rod.
Yeah.
So can you just say the center of mass might not be... can be modeled. Oh.
Yeah.
The center of mass is in the middle of the ore.
Yeah, so I think the way you model it is that the weight is all concentrated in the center. The mass of the ore is unlikely to pass through the midpoint of the ore. What?
What does that even mean?
It should be the other way around, shouldn't it? Comment on the assumption that the ore
can
be modeled. Oh, okay. So basically, so what they're saying is like someone models this ore as being a uniform rod, but that's a pretty terrible model because clearly the center of mass is going to be closer to the heavier end than in the middle. So, okay. So what they were saying is like if you have to comment on that model, you should say that's a bad model.
Oh, that's what I said first, and then I got confused.
Yeah, I didn't really get it.
It's weird ones.
But let me see. Okay, this one looks good. Let's try this one.
Wait, 100 meters and length 4 meters.
I'll just be a sec. Sorry about that. How did you get on with this one?
I think I know how to do it.
Go on.
So the point like where it's attached to the wall, I think that should be the pivot.
Okay.
So if you take if you take moments about P, then you have 100n times D, because you don't know the distance. Yeah, 100 times D. And that's going clockwise. And then plus 80 times 80 sine 30. I don't know if that's correct. Yeah, is equal to 0.
And what do you get there?
I don't know if like the 80 sine 30 bit is right. 32. Okay, that's wrong. Yeah.
The rod is attached to the wall at... Oh, okay.
Oh, it's 4 sine 30. Never mind.
184 sine 30. Yeah, sorry. That's... So... Try 4 instead of 80.
Yeah, 1.6.
So that's 1.6 meters. 4, yeah, distance times... Yep. Any questions there?
Yeah, why is it not 80 sine 30? Is it because 80 is the force and
80,
not
80 is the force.
okay?
80 sine 30 is the force.
But if you did 4,
So
how would you do 4 sine 30? Because 4 is the adjacent side, so why would you do that?
So it's like you should, if you like that, 80 sine 30 times 4.
Okay.
4 is the distance, and then it
Okay.
would, if it was straight up, it'd be 80, but it's at an angle.
So it's always sine, basically, for moments.
Yep.
Okay.
Center of mass.
Yeah, I mostly understand it.
That's good. Tilting. Tilting means the force is it's about to rotate, and so the reaction is 0. So let's try this.
Any other? So, like, you know, when it says the beam is on the point of tilting about C, does that mean the force at D is 0 or the force at C is 0? Like, which one?
D.
Okay. So everything is like on C.
Yeah.
Okay. So there's 45G going down at like 8 meters. And then when the child stands there. Okay. So then you have 45G times 3. If you take moments about C, sorry.
Okay.
And then M times 5M. Plus. Wait, no, minus. Would it be equal to 0?
I'll just leave it like that. I just want to see something here. So uniform beam A to B. The mass is 45G. Length is 16. So that's 5. That must be 3. C and D. C is 8. C is 4. Yeah. When a child stands at A, the beam is on the verge of tilting there.
No, it says about C.
Yeah.
Yeah.
Find the mass of the child. So you took moments about C. And so 5. If you're taking moments about C, then I think this would be plus. Maybe it makes no difference.
But wouldn't it be going the other way? One of them has to be negative because they're going to go in opposite directions.
I think, let's see. So find M. Calculate M. See what you get.
Yeah. 264. That's not right. 0.6. But that's wrong.
So I think it's just a different thing. Let's see.
It might not be equal to 0, I guess, but I don't know what it would be equal to.
So
it's definitely like no other force, so
taking moments about C.
I think we forgot the G.
Shouldn't 3 times.
We did put G.
5G. Go on, put in G.
Wouldn't that just be 264.6 divided by 9.8? 27. That's a reasonable answer.
27 kilos. 27 kilos, yeah. That's good. Just a G. Okay, I think that's good. Let's try this one. Non-uniform.
Diagram. So, is it like rotating about A? It's not really clear. So, like about C, like which one would be 0?
So you just kind of think about it. So it's suspended.
I feel like it would be about like C.
Try C. So from
that means C would be 0.
So if you hung something from A at A, would the tension in C increase or decrease?
Increase.
So then the tension can't be 0 if it's increasing.
No, wouldn't the tension at D be 0 because it's going to tilt about C?
Yeah.
Yeah.
So it's the D one that goes to 0. This one, this rope would almost become slack. This one is
So there's 25 times 3 if you take moments about C. And then minus 40D. What's wrong?
D is 0.
No, I meant distance. Should probably use a different letter.
Okay. I'll use small d.
Okay. is equal to 0. D is 1.875. But that's from C, right?
That's from C.
875. And then, so from A it would be 4.87. Or 88, yeah.
Okay, great. Grand. I think it's good. Let's see if these are worth doing. Uniform plank. AB 80. Man walks along the plank. Is this worth doing? I think it's okay. Uniform plank.
So the one at A would be 0.
A man walks along the plank to the point D.
Yeah, because it's going to rotate about C, so A would be 0. Because it says AD is equal to 9 meters, so it's like past C.
Yeah, and it would have to be. Yeah.
So A would be 0, right? Yeah.
Yeah.
So then if you take moments about C, I suppose, why not? You'd have 2 times ATG.
Well done. You remember the G?
Plus would be going, wait, no, minus. It's going a different way, different direction. 2 times 2G times X.
Where are you getting 2 from?
It's 9 meters from A, and that's 7 meters from A, so that has to be 2.
Uh-huh. That is it?
Yeah, that's all. I think this is like a lot of marks for just writing in the page.
Okay, go on. What do you get for this one?
X is 80.
80 kilos.
Kilograms.
80, yeah, okay. This looks similar.
Yeah.
Yeah, it looks similar. Same.
I don't like that one.
This time it's non-uniform. The only difference here is there's no diagram to help you, but I think you're okay. Oh, let me see. Worker 5x, non-uniform. I think you're gonna be fine, personally. This looks worth doing. Yeah.
Oh, so many letters everywhere.
Yay.
Well, it tells you where the center of mass is. So you could put mg on there. It's not really useful, but...
Well, what does it say? The center mass is O?
Yeah, the point O. So mg. So the like moment around M, or like the forces, is 0 because it's going to tip around N.
Yeah.
So then you have mg. Don't know what the distance is, so do you? Yeah.
So what are you taking moments about, or what are you doing?
Oh, I'm taking moments about N. So then you'd have 3/4 M times 2A. Yay.
3/4 what, sorry?
mg
mg, yeah.
times 2A minus mg times something.
times distance or something?
Yeah. Is equal to 0. How do we solve that?
Well, you can divide everything by g.
Yeah. And m for that.
Correct.
So 6 over 4a.
Sure. But you've still got two unknowns. Oh, show that ON is that. So 6 over 4a is the same as 3 over 2a, isn't it?
Yeah, because you'd have, if you divide by mg, you'd have 6 over 4m is equal to d.
Yeah.
A, sorry. Yeah.
So I thought they actually want, yeah. And then B.
So it's now at 4a. So you'd have to do moments about n again. Right? No?
Wouldn't it be, if you did that, wouldn't you get 0?
Oh, get rid of the tension. About m, I suppose.
I think it'd have to be M.
So you'd have mg times 4a. Wait, no, not times 4a. Times...
This distance is A.
Yeah. Mm. (3.5a).
How did you get 3.5?
I did 8 minus 2, like nq, and then minus 3 over 2, which is like on. So that means the rest of that is...
Hold on. What are you... You're saying the midpoint. You're saying the O is mg, is it?
Yeah.
Okay. So that is, okay, 3.5a.
Yeah. And then there's the particle 3/4 mg.
Hold on. Where do you get 3.5?
I did 8 minus 2, like the nq distance, and then minus 3 over 2, which is on, which is 4.5. So that means like O to P is like 4.5.
Okay.
And then minus 1.
Okay. All right, go on.
Minus 3/4 mg times 3a. Yeah. And solve. No, what is solve?
Of the tension in the wire in terms of M.
So I don't know how taking moments. Oh, so do you have to? Oh, you have to include the tension at n in the moments, which we didn't do, and we probably should.
Yeah, we need that.
So that would be T times. Does it tell you how far it is? Oh yeah, it does. 5a, I think. Yeah. Yeah. Would it be minus or plus? Plus.
Plus, yeah.
Wouldn't the mg and the particle be going in the same direction?
So we're taking moments about M.
Yeah.
So
Going down.
They should both be minus, I believe.
And then we solve for T.
So how do you do that?
Okay, you can't really divide by mg. You could divide by A. right?
Yeah.
It's not really super helpful, but
It is to me.
so then you could multiply, so like minus 3.5 mg, then minus 2.25 for the second one.
Sure. And you could throw them off to the other side.
Yeah. Oh, it's times 3.
So that was 9 over 4.
904.
So 2.25, okay.
Yeah. Now you can add them together,
Uh-huh.
which is 5.75, and then it's equal to 5t. So that means if you divide both sides by 5, you get t is equal to 1.15 mg.
So T is equal to 1.15 mg.
You can divide by g, I guess, but you need to. It becomes a fan.
I don't know.
Then too.
23.
Yeah, same thing.
Same thing. Great.
Mhm.
Any questions there?
No, it was just long, but it's not that hard.
So these ones, I just want to see. I don't know the thing. This one, you've got 2 strings, and it's there. Yeah, 2 strings. I think we just did a more challenging one, arguably.
Yeah, this one doesn't look that long.
And then this is similar to the one we just did, where its overall was 8, and then you had this and this. So this time, hang on, D to B is 2D. So that's very similar to the one we just did. If that's D, that's 2D. This must be 2D. That's similar to one we just did. The range of possible values of x. That's an inequality, is that right?
Oh no.
X is between 0 and 0.8. So
like inequality.
So that one. Let me just.
How would it be 0?
I think,
distance of x meters from D. Okay,
yeah.
so it's just at D.
So you would just.
But you know, when you do that, how do you know like which side it is? Like, how do you know if it's DB or like DA, or like does it not matter?
It does. If you put something here,
Yeah.
it won't tilt because it's got the supports on either side.
Yeah, but
So the
you
only
know the
way.
range of like values of x. How do you know if it's like 0.8 meters to the left or 0.8 meters to the right?
So if it was here, it won't tilt.
Okay.
Because it's got a support either side. So the only way it can tilt is if it's here.
But it says the rod remains in equilibrium, so.
Then move to position between.
It's between D and B. Okay, I didn't read that part.
That's all right. And yeah, usually it'll say something about tilting. The other possibility, like for a different question, would be it could be there, and that would cause it to tilt the other way. Up off D. And so tilting.
Yeah, it's fine.
And let me just check. Yeah, so that's all of that chapter. Anyway, how was that for you, Amogha?
Pretty good. Moments isn't that hard.
And so, any topic in particular you want to do next time?
I don't really know.
We can take a look now, friends.
Maybe parametric equations. I've done like a bit on them, but not like loads.
Okay.
Yeah, fine.
Any questions for me in general?
You know the questions that you like send me for like work. They have, I don't know if it's like a mistake like on our computer, but they have like a yellow lines around them.
Oh.
Yeah, and so like when I print it out, it takes like loads of ink. I was just wondering if it'd be possible to,
Okay. Yeah.
or
Most people don't print them. But yeah, okay. So try to make the background white. Oh look, I'll make background white. Okay. Anything else?
no.
All right.
Thank you.
Well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.